Hello everyone, GarethTheMaster97 for you again today, and welcome to another Valve source code tutorial. This time around I'm going to demonstrate how to create a laser gun, which basically fires a laser beam that does damage and adds decals to wherever it hits. And it's also going to be the first time I'm going to showcase how to do networking, which is that we have code on the server side that's going to get linked to the client side. So the server side is going to handle stuff like animations and depleting ammo from the weapon, and the client side is going to be dealing with the decal drawing and the beam drawing side of things. So it's going to take some bits of code from the fizz gun, from the tau cannon, and even the fire extinguisher. So let's just get started. So you want to go to your games solution, wherever that's located, boot into it, and on the server side I'm using server HL2. You want to add a new item somewhere on the server, and I'm going to call it something like weapon underscore ion tau. I just like to imagine it's called the ionic tau cannon for some reason, so it's just a more sustained fire version of the tau cannon. And we're going to start off with our include files, so what external header files are we using. That's going to help us with the code here. And so we're going to start off with hashtag include cbase.h, include ammo.def.h, in underscore buttons.h, and the last one, which is pretty much always tr0/memdbgone.h. And we're also going to do some definitions here. So we do hashtag define, and in my case I'm going to say something like ion tau underscore ammo underscore rate, and this is going to be the rate at which ammo gets consumed by this weapon, and I'm going to set this to be something like 0.2, though if you want it to deplete ammo faster then you decrease this number, and if you want it to deplete more slowly then you increase this number. But it's basically just a way, when we get into the code later, of making sure that our ammo steadily decreases as the weapon's being used. After this we're going to do hashtag define ion tau beam sprite, and this is going to be sprites /bluelaser1.vmt. As we are on the server we have to specify a .vmt extension, but this is going to be the material that the laser beam itself is going to draw with. Not that we're doing it on the server, but we still need to pre-cache the material. And we're going to have hashtag define ion tau attack rate, and I'm going to specify this to be 0.0625 or 1 divided by 16. So this is going to be how many times the weapon's going to be actually doing damage per second. So instead of doing it on a per frame basis, we're going to do it on a per second basis, and so we're going to specify a delay in which damage attacks are actually caused to stuff like NPCs. And we're going to create a static int called g underscore ion tau beam. I don't know if you need to do this, and I think I should say at this point I don't know if some of this stuff is stuff that you need to do, but you can do it anyway just to be on the safe side. And so at this point we can declare our class, and I'm going to call it something like cweapon ion tau. And what is this going to be? Well, it's going to be a public C-base combat weapon, or at least it's going to derive from C-base combat weapon. And so inside this class we're going to declare a data desk, and we can get into our public methods or public functions already. And so we're going to start off with a declare class. We're going to declare our C-weapon ion tau as a C-base combat weapon. And we're going to go into the constructor, so it's just C-weapon ion tau. Then we're going to have void spawn, void precache, void primary attack, void weapon idle, and void item post frame. Now you don't actually hear me say void as an input parameter. You could just leave that as blank, but basically it's going to output void and it has no inputs, so there's void inputs. That's what I'm saying at this point. We're going to have a virtual ball called holster, which is going to pass through an input of a C-base combat weapon called *p switching 2. And inside this we're going to say a int that we're not defining yet called m underscore active equals false. It will throw up an error at this stage, but don't worry, we'll define m underscore active later. And then we just want to return base class : holster. And we don't need to pass through p switching 2 here, but if you want to, you can do. But in my case, I'm just not going to do that. Then after this, we're going to have void effect update void and void add view kick void. And to declare a server class as well. And onto our private, or in my case, I'm defining them as protected variables. So for networking to work, to be able to pass through stuff on the server to the client, we need to use a network property of some description. So we're going to start off with a C network vector, which we're going to call m_target position. We're going to create another C network vector called m_world position. We're going to have a C network var, which is going to be of type int, and it's going to be called m_active, and another C network var, which is going to be of type int, and it's going to be called m_viewModelIndex. And we're just going to have a local float called m_fl next attack time. So this next attack time is only used on the server, so we don't need to pass it through to the client. So that's why it's just a standard float and not a network var, for example. And so now we're going to implement our server class st, which is going to be for our C-weapon IonTau class, and it's going to be dt_weapon IonTau after this. We're going to have to refer to this on the client side, the client class implementation. And so the first thing we're going to do is send prop vector, send info_name, m_target position, m_target position, and after this -1 and sprop coord. And then we want the same thing, except for, instead of target position, we're going to have world position. So it's going to go send prop vector, send info name, m_world position, m_world position -1 sprop coord. Then we want to send prop int, send info. I know I put send info name in the video, but you just want it to be send info, m_active, then 1 and sprop unsigned. And then we want to send a prop model index, and we're going to send info, m_viewModelIndex, and then end the send table, which I already put that line in, but in the video. So you want it to look a bit like what I show on the screen, except for where I say send info_name in m_active, we just want it to say send info. So after this, we're going to link entity to class, and I'm going to call it weapon_IonTau. This is what your weapon is going to be called if you're going to create it in the Hammer editor or spawn it with the developer console. And this is going to be based off of our C-weapon IonTau class. And we're going to pre-cache a weapon register for weapon_IonTau. After this, we're going to begin a data desk for C-weapon IonTau. And much like I did with the server class, I'm just going to put end data desk immediately after this, and then press enter at the begin data desk line to then go inside of begin data desk and end data desk to actually put our define_fields in, which we're going to define a field of m_active as a field integer, m_viewModelIndex as a field integer, m_target position as a field position vector, m_world position as a field position vector, and m_fl next attack time as a field time. So after this, you can go into the constructor, which is C-weapon IonTau : C-weapon IonTau. And inside this, we're going to say that m_active is false, m_target position is vec3 origin, which is just shorthand for 000. Same thing for m_world position, it's vec3 origin, and our m_fl next attack time is 0. So after this, I don't know if you have to do this, but I'm doing it anyway. We're going to do void C-weapon IonTau spawn, and in this we're going to do base class spawn and fall init. After this, we're going to do void C-weapon IonTau precache, and in this we're going to do base class precache. But we're also going to say at this point that our g_IonTau beam static int that we defined earlier is actually going to be equal to precache model of our IonTau beam sprite. And next we're going to do void C-weapon IonTau effect update. So we're going to say that m_active equals true. We're going to create a vector, start, angles, forward, right, and up, as shown in the video, and also a trace_t called tr. We're going to create a C-base player called *Peona, which is equal to base player get owner, as shown in the video. And if !Peona is null or !Peona then return, so exit out the function if we don't have a player. Then our m underscore view model index is our p owner, arrow, and index. And we're going to create a C-base view model called *VM, which is p owner, arrow, get view model. And then if we have a view model, so if VM, then we're going to say that our m underscore view model index is VM, arrow, and index. Then we're going to do p owner, arrow, I vectors, and forward, and right, and up. We're going to set start to be equal to p owner, arrow, weapon underscore shoot position. We're going to create a new vector called aim_dir, which is p owner, arrow, get auto aim vector, and you can choose whatever you want here, but I choose auto aim underscore 5 degrees. We're going to create a vector called end, which is equal to start plus forward multiplied by something. I'm just going to use 4096 here, but you can use whatever you want. And then we're going to do vectors of aim_dir, right, and up. And then we're going to use a util trace line going from our start vector to our end vector. It's going to be mask shots, p owner, collision group none, and tr. Then our end is going to be equal to our m underscore world position, which is going to be equal to our tr.endpos. And our m underscore target position is going to be equal to start plus forward multiplied by something like 25, but you can use whatever you want here as well. So then after this, to be able to do damage, we're going to say clear multi-damage, and then create a C-base entity called *p_hit, which is equal to tr.m underscore p_ent. And so this is where we're going to do damage. We're going to create a little loop here. And so what we're going to say is that if our m underscore fl next attack time is less than gp global's arrow cur time, then what do we want to do? Well, first of all, we want to check if we've actually hit an entity of some description. So we'll say if p_hit does not equal null, then we're going to create a c take damage info called damage info. And in brackets, we're going to put this, p owner, something like 3, and damage underscore shock. Bearing in mind that I defined the attack rate earlier as doing 16 times per second, effectively it's going to do 48 damage per second. So that's why we set the number low to something like 3, because we're going to bank on the fact that it's going to be doing multiple attacks per second. We're going to calculate a bullet damage force for and damage info, and m underscore I primary ammo type, aim_dir, and tr.endpos. And then we're going to say p_hit, arrow, dispatch trace attack, damage info, aim_dir, and tr. Outside of this, we're going to create another if statement. If tr.DidHitWorld, and in a new set of brackets, tr.surface.flags and surf underscore sky. So if we hit the world and we did not hit the skybox, then what do we want to do? So there should be an exclamation mark here in front of the brackets that says tr.surface.flags. But we're going to do util underscore impact trace, and this is going to be and tr, get ammo def, brackets, then arrow damage type, and in more brackets, m underscore I primary ammo type. And then we're going to use our impact Gauss effect. So then after this, we're going to use util underscore decal trace, and it's going to be anti-tr, and it's going to be red glow fade. And this is if you want to have server-side decal effects, but I'm going to showcase how to do client-side effects because server-side decal effects didn't work, but that's because I mentioned just that there needs to be an exclamation mark at the tr.surface.flags condition. So it's if we hit the world and we did not hit the skybox. So if we hit the skybox, then there's going to be an effect, and we don't want it to do that. So then after this, we're going to create a CPVS filter called filter, and this is going to be at our tr.endpos. And we're going to say TE for temporary entity, arrow, Gauss explosion, and in this we're going to say filter 0.0f tr.endpos tr.plane.normal and 0. So then outside of this, we're going to apply our multi-damage, and we're going to do another util underscore impact trace, and tr, get ammo def, brackets, arrow, damage type, and in brackets, m underscore I primary ammo type. And after this, it's going to be the impact Gauss effect again. we're going to create a vector called recoil force, which is equal to p_owner arrow body direction 2D. And we're going to say this is going to be multiplied by the negative value of 2 times 10.0f. Again, you can use whatever numbers you want to use here. And we're going to say that our recoil force, and in angled brackets 2, so the z value is going to be plus equals 5.0f. And then we're going to say p_owner arrow apply abs velocity impulse of our recoil force. We're going to add a view kick, and then say that our m_fl next attack time is equal to GP global's arrow cur time plus our ion tau attack rate. So this end line allows this to loop over and over and over again. So our next attack time is going to be less than the current time, then the current time is going to increase, so then it's going to trigger this loop, and then it just goes on and on and on and on and on forever. And so for the absolute velocity impulse line, that's going to add a little bit of kickback. And you might want to experiment with the numbers to give extra kickback, or maybe not so much kickback. So that's why we do what we've done there. And so after this, we're going to do our void C weapon ion tau add view kick. And so we're going to have a C base player called *p player, which equals to base player get owner. If !p player, then return. We're going to create a Q angle called view punch. And we're going to say that our view punch.x equals random arrow random float minus 0.4 to 0.4. And same for the y value of view punch as well. And we're going to say that view punch.z equals 0. And then we're going to do p player arrow view punch of our view punch Q angle. After this, we're going to create a void C weapon ion tau primary attack. And we're going to create a C base player called *p_owner, which equals to base player get owner. And if !p_owner, then return. We're going to say here that if p_owner arrow get ammo count of our m_I primary ammo type is less than or equal to 0, then we want to say that m_active equals false and then return. So we don't want to be attacking if we have no ammo for our primary ammo type, which is going to be defined in our weapon script. Then after this, we want to say else if !m_active, then we want to send weapon anim act_vm_pullback, which is specific to the view model I'm using, which is a Gauss gun model from missing information. That way it does the sort of looping effect for the Gauss gun charge. Then we're going to say p_owner set arrow set animation player attack 1, and then m_active equals true. And then outside this, we want to say else effect update. Then outside of this, we want to say if m_fl next primary attack is less than GP global's arrow cur time. Then we want to do p_owner arrow remove ammo 1, and then m_I primary ammo type. We want to have weapon sound single. We want to add our view kick, and then do m_fl next primary attack equals GP global's arrow cur time plus our ion tau ammo rate. So this bit of code is going to be responsible for depleting ammo from the weapon in a steady fashion. After this, we're going to have void C weapon ion tau weapon idle, and we're going to say send weapon anim act_vm_idle, and then if m_active, we want m_active to be false. After this, we're going to create void C weapon ion tau item post frame. So we're going to have a C base player *p_owner, which equals to base player get owner, and if !p_owner, then return. If p_owner arrow get ammo count of m_I primary ammo type is less than or equal to 0, or in another set of brackets, p_owner arrow m_if button released and in _attack, then we want to say m_active equals false, want to weapon idle, and then return. And then after this, we want if p_owner arrow m_n buttons and in attack, we want to primary attack, else we want to weapon idle and then return. And so I think you'll be happy to know at this point that this is the server side code done. So you want to navigate to the client side code, So if you've done this in server HL2 like I have, then you go to client HL2. If you've done this in server episodic, then you go to client episodic. And on this client project, you want to create a new file. So I'm going to call it something like c_weapon_iontau to keep in convention with naming in the Half-Life 2 code. And so in this code, we're going to hashtag include cbase.h again, but we're going to also hashtag include beamdraw.h, include c_weapon_stubs.h. We're going to include client effect precache system.h. And last but not least, we're going to include tier0/memdbgone.h. We're going to do client effect register begin of precache effect iontau. We're going to have client effect material, and it's sprites /blue laser.1, but we're on the client, so we don't need to specify the .vmt extension here. And then we're going to do client effect register end. And now we're going to define a class called c_iontau beam, which is a public C default client renderable. So this is going to be the actual beam entity. So we're going to start off with our public methods. So we're going to have our constructor c_iontau beam. We're going to have void update, which is going to pass through a c_base entity called *peona. We're going to also define a matrix 3x4_t called z, and we're going to have const matrix 3x4_t and renderable to world transform, and in this we're just going to say return z. This is one of the necessary changes that we need to get the beam drawing to work. We're going to have a virtual const vector and called getRenderOrigin, and it's going to be return m_world position, as you'll see in the video. We're going to have a virtual const qAngle and called getRenderAngles, and this is going to return a vec3_angle as shown in the video. Then we're going to have virtual bool should draw, and this is going to return true. We're going to have a virtual bool called isTransparent, and this is also going to return true. And we're going to have a virtual bool called should receive projected textures, which is going to pass through an input of int flags, and this is going to return false. We're going to have a virtual int called drawModel, which is going to pass through an input of int flags. And we're going to have virtual void getRenderBounds, which is going to pass through an input of vector and mins and vector and maxs. And we can define this here as mins.init as -32, -32, -32, and maxs.init as 32, 32, 32. And then we're going to have a c_base entity called *m_peona. We're going to have a vector called m_target position. We're going to have a vector called m_world position, an int called m_active, and an int called m_viewModelIndex. So pretty much what we defined as network parameters on the server side, but here on the client side we don't need to do that. So we're going to define a class called c_weapon_iontau, which is going to be a public c_base combat weapon. So this is the client version of our iontau weapon. And so we're going to declare a class called c_weapon_iontau, which is a c_base combat weapon. And we're going to create our public methods, which is going to be c_weapon_iontau. And we just put our curly braces here to mean that we're not going to be constructing anything. We're going to declare a client class. We're going to declare predictable. We're going to have void onDataChanged, which is going to pass through an input of data update type _t called update type. And here we're going to say base class onDataChanged update type. And after this, m_beam.update, and in brackets this. So m_beam we're going to define right now. It's going to throw up an error, don't worry about it. And after this, we're going to create our private parameters, which we're going to have c_weapon_iontau, which passes through an input of const c_weapon_iontau and then we're going to have a c_iontau beam called m_beam. So at this point, we're going to do stub_weapon class implement, and it's going to be our weapon_iontau, like we'll call it in the Hammer editor or our developer console, and it's going to be a c_weapon_iontau. we're going to implement client class DT, which is going to be our C underscore weapon ion tau class, a DT underscore weapon ion tau as we said on the server, and also C weapon ion tau as we said on the server. That way it links the code together from the client and the server. And so we're going to have a recv prop vector, which is going to have a recv info name of m underscore beam dot m underscore target position, which we're going to call m underscore target position. Then the same thing, but for m underscore world position instead. We're going to have a recv prop int of recv info name m underscore beam dot m underscore active, which is called m underscore active as shown in the video. And last but not least, recv prop int recv info underscore name of m underscore beam dot m underscore view model index, which is called m underscore view model index, and then end the recv table as shown in the video. So we're going to go into our ion tau beam code. So we're going to have our constructor to start off with, c underscore ion tau beam, c underscore ion tau beam, and we're going to say that m underscore peona equals null, and that m underscore h render handle equals invalid client render handle. Next, we're going to have void c underscore ion tau beam update, which is going to pass through an input of c underscore base entity asterisk peona. And what we're going to say is m underscore peona equals peona. And if m underscore active, we're going to say if m underscore h render handle is invalid client render handle, then we want to do client leaf system arrow add renderable this render group translucent entity, else client leaf system arrow renderable changed m underscore h render handle. Outside of this, we're going to say else if exclamation mark m underscore active and m underscore h render handle does not equal invalid client render handle. Then we want to say here that client leaf system arrow remove renderable m underscore h render handle, and then set m underscore h render handle to be invalid client render handle. And so now for a pretty juicy bit, we're going to have int c underscore ion tau beam draw model, which passes through int flags. So this is going to be where we actually draw the beam on the client side. So we're going to create a vector called points, but it's going to be an array which has 3 elements to it, a start, a middle, and an end position. And we're going to create a Q angle called temp angle. We're going to say if exclamation mark n underscore active, we're going to say return 0. So if we're not active, we're not drawing the beam. We're going to have a c underscore base entity called asterisk pent, which equals cl underscore entity list arrow get ent, and it's m underscore view model index. Then we're going to say if exclamation mark pent, so if we don't have an entity, then return 0. So we're not going to draw the beam. After this, we're going to say pent arrow get attachment 1, point 0, and temp angle. Next, we're going to have point 1, which is going to be 0.5 times our m underscore target position plus point 0. And for a bit of variation along the beam to make it not look like a straight beam, much like we've commented out physgun code, we're going to say point1.z plus equal 4 times the sine of GP Global's arrow cur time times 11. And we're going to add on to that 5 multiplied by the cosine of GP Global's cur time multiplied by 13. That way we get a bit of wobbliness going on with the laser. And we're going to say point 2 is m underscore world position. So then after this, we're going to have an I material called asterisk pmat, which equals materials, arrow, find material, then sprites / blue laser 1 in speech marks. And this is texture group client effects. We're going to have a vector color, and then we're going to do color.init 001. So it's going to be pure blue with 0 red and 0 green. We're going to create a float called scroll offset, which equals GP Global's arrow cur time minus the integer value of GP Global's arrow cur time, and that's how we go about doing this, as shown in the video. And we're going to have a CMAT render context PTR called prender context and in brackets materials. Then we're going to say prender context arrow bind pmat, and then we're going to draw beam quadratic points 0, points 1, points 2. We're going to have a width of 13, the color vector, and a scroll offset, and then we're going to return 1. And so you can compile the code and see that it works. The one thing that I haven't done is gone over the actual weapon script, which I'll outline. But basically you can give it a name, you give it a view model, a world model based off of whatever you have. A bucket position is where it's going to be shown in the HUD. And the ammo type, primary ammo type, clip size, default clip size, weapon sounds, and HUD visualizer icons and stuff like that. So you can take a look at what I have as a guide for what you want to do to set up the Ion Tay weapon. It has to be in your mods scripts folder. And so because I mentioned earlier on the server side that I did something incorrectly, I'm going to go over how to do decal drawing on the client side now. So if you want to do this, you want to go to the top of the client side file and you want to hashtag include decals.h and also include iefx.h. Under something like updates, you want to have void add decal and then in brackets trace underscore t and tr. And then somewhere after this, say above draw model where we actually go for the code, you want to say something like void add decal trace underscore t and tr as shown in the video. Then we want to create a c underscore base entity called asterisk ent, which equals cel underscore entity list arrow get ent 0. Then if ent does not equal 0, then we're going to create an int index, which equals decal system arrow get decal index for name of, say, red glow fade. Then if index is greater than or equal than 0, then we're going to create a vector called end position. We're going to say endpos.random -4 and 4, so it's going to randomize a number between 4 and 4, and our endpos plus equals tr.endpos, so it's going to vary around the end position. And then we're going to do effects arrow decal shoot of index 0, get model, get absolute origin, get absolute angles, end position 0 and 0 as shown in the video. And the get model, get absolute origin, and get absolute angles is going to be ent in front of it, ent arrow, as I said, as shown in the video. And then in the draw model code, you want to create a trace underscore t called tr. You want to do util underscore trace line of points 0, points 2, so the start and end position, mask shot, null, collision group none, and tr. And then after this, you want to do add decal tr. And so basically what this does is when you fire the weapon, you'll notice the beam has a bit of wobbliness to it. The decals draw, and if you look closely, you'll see that the decals actually sort of appear and disappear. But if you move, then you'll get a whole load of decals being drawn, which is probably the downside of doing the client-side version of decal drawing. The view model, because like we said, it was a pullback animation, it's going to be doing the charge as if you'll be charging up the Gauss cannon. And it's also going to be depleting ammo at a fairly steady rate. And it's also going to be doing shock damage to any enemies that you hit. So that is pretty much how you create a laser gun using networking. So I hope you found this tutorial helpful. I know I stumbled and screwed up in parts, but I've done this all in one take and spent about 35 minutes doing this. So I hope you found this very helpful. Please let me know what you think. And I'll see you for the next video for whatever I decide to do. So yeah, take care out there everyone, peace out as I hit my remote and table, and see you next time.